Okay, so in this session, we're going to find out what mining is and how mining works. You must have heard that mining is the process of adding a block to the blockchain, where nodes, the special nodes or miners, basically try and solve mathematical puzzles using computational power to add a block to the blockchain. But how? What exactly is that mathematical problem? Well, it's quite easy to understand once you get a better understanding of what hash is and how hash function works. Okay, so understanding hashes is the first step in understanding mining. A hash will take an input of any length and generate its seemingly randomized output of a specific length. The same input will always generate the same output, but changing just one character will drastically change the output. So let me give you an example. Like I mentioned, a hash function is any function that can be used to map data of arbitrary size onto data of fixed size. So what exactly does that mean? I mean, you can just put in any data for any length, right? You can put in hello, you get a different hash. You put in something like your name, you get a different hash. You put in some numbers, you get a different hash. You can put in the whole of the Wikipedia and you still get an output of fixed length. So that's what is hash function. Common algorithms that we can think of. So imagine we're using the SHA-256 algorithm for this instance, which is the same, algorithm that's used by the Bitcoin blockchain. The SHA stands for Secure Hash Algorithm. It was created by the National Security Agency. So we have SHA-256, SHA-5112, and for Ethereum we have something called as the ETH hash. So basically they just convert any data of arbitrary size into a data of fixed length. Okay, so to get a better understanding of how the hash function works, we can take an example. So I'm using the blockchain demo here. So we're going to use the SHA-256 hash. Now imagine I'm putting in a data, or I'm just going to type in my name. I get a hash of a fixed length, and if you notice, the last 3 digit is DEA. Now even if I just put a full stop to my name, the hash completely changes, right? And I just do I type in something randomly and I get a different hash. Okay, so this behavior makes it very difficult to predict what input gives a particular output. For example, if I put in something like, hello world. This is the output I get for hello world. And any sort of a space or even a full stop will make, completely change my output. So in mining, the miners have to achieve a hash with a numeric value lower than the specified number. The number is called the target. If your hash attempts gives you a number less than the target, which is the same thing as having a bunch of zeros in front of the hash, then you win and you will get to mine the block. To find such a small hash takes millions of attempts, or more accurately, the whole mining network with everyone trying to at the same time need millions and billions of tries to get it right. This part of the content that they are hashing are all allowed to change a single number. In order to try and get a hash beginning with zeros, it's called the nonce. Like I mentioned, the current block reward of 25 Bitcoin is given to the miner who successfully mines the block. The current block reward of 12 Bitcoin is given to the miner who successfully mines the block, basically trying to find the right hash. Okay, to make any sense of Bitcoin's solution to this problem, you need to also understand what is meant by distributed timestamp server and how the proof of work can be used to construct this. It's very briefly explained. If you take the white paper of the Bitcoin blockchain, you'd be able to get the explanation in section 3 and section 4. You're creating a sequence of blocks tied to each other by including the hash of the last one in the next one. So the current hash, now for example, if I take this particular block, it would, I'm sorry, let's take the block 2. It would contain the hash of the previous block. If you notice, the block 1 has 7CF as the hash, and the block 2 will contain 7CF. So it contains the hash of all the previous block. Okay, this proves that next block knew about the last block, right? Remember, hashes are not totally unpredictable, which proves that it came afterwards. However, that is not enough. You know that block 8 comes after block 7. But what if the different block 8 put in by a different miner also comes with block 7? Or just imagine if these two competing blocks 8A and 8B contains different transactions spending more money to different places. Which one is true? The reason miners did the complicated proof of work process above is exactly to solve this process. Okay, and in Bitcoin, the chain of blocks with the largest total proof of work embedded in it is the winner, right? So any blockchain which has the right amount of blocks, or if 51% of the nodes agreed to validate the block, it then gets added to the block and it becomes part of the blockchain. Okay, the reason this is a good way of deciding is that it makes it incredibly difficult for an attacker. For example, if we have someone who wants to spend the Bitcoin twice, or to create an alternative single block or chain of blocks, or try to convince everyone on the network that theirs is the right one, to be valid, you would have more proof of work in it, right? A lower hash value or a more subsequent block. Since everyone else is working on the true chain, they have an enormous amount of CPU power working together to create it. To beat them, you're going to have to, have more CPU power than everyone else. Hence the 51% attack. If you've heard about the 51% attack, it means if you are able to take control of 51% of the nodes, and you will be able to make the blockchain immutable, or you can add the block to the blockchain and state that it's the valid block. So proof of work makes sense because work cannot be faked. So what do you think is the math problem these mining computers solves? It actually has no purpose other than to secure the Bitcoin's network from attackers wishing to double spend, basically. Just imagine I'm an attacker and I'm trying to actually change some value in this particular block. If I'm trying to send my friend $500, I just say that I'm sending $600. I try to do some sort of changes. If you notice, every other subsequent blocks that come after it turns red, which means it's an invalid block, right? So like I told you, sorry, every block would contain the hash of the previous block, which is why blockchain is the Bitcoin blockchain, or any blockchain for that matter, is immutable. So you can't make any sort of changes, and if you do try to make some sort of changes, you need to basically try and mine every other block. Now, for example, I make some changes here. I need to mine it to get the right hash. I'll have to mine this block, then I'll have to mine every other block that comes after it. So you get the point, right? Okay. So imagine we have a distributed blockchain. Now, what is DLT, distributed ledger technology? Imagine we have a lot of nodes, right? Nodes that are in the network. So we have peer A, peer B, peer C. So everyone has a copy of the blockchain. Now, even if I sort of make any changes in this particular block, for instance, I try attacking peer B, every other block actually kind of turns red. which makes it an invalid blockchain itself. Now, how can I say now? Even if we try and mine this block and make it a valid one, if you notice, the hash of this particular block C 133, is different from the block 3 of pure A, right? The blockchain is built in such a way that the network automatically chooses the majority. So the block that was added in the recent blockchain, even if it's an invalid block, okay, we have the other nodes start validating the blocks